Okay, everyone, welcome to our part 2 of our Polygon worksheet. Previously, in the first part, we explored what is the sum of the interior angles for our polygons. And today, we'll learn all the other properties and try to apply it to the questions. Okay, alright, so for our polygons, so previously polygons, we talked about polygons being shapes of many sides, okay, and we need to know the shapes and the names. So all the names over here are things that we need to know, alright, triangle all the way to decagon, right? So all these we have to know, and the sum of interior angles of this polygon. So for a triangle, all the angles within the triangle add up to 180 degrees. Right, for the quadrilateral, for a shape with 4 sides, it adds up to 360 degrees. Right, then previously from pentagon we have 540, and for hexagon we have 720. For heptagon we've done 900. Now if you're not sure, you can actually use one of the two formulas below. Okay, one of the two formulas here below to do your calculation, and you just put n. Okay, just substitute n as the number of sides, and then you can get all these values. Okay, now for an octagon, the sum of interior angles would be 1080. Okay, for nonagon, it would be 1260. For decagon would be 1440. Okay, and as you can see, right, okay, on top of the pattern being the formula, the general formula, you can think of it as every step you go, you are adding 180 degrees, if you can see this relationship. Okay, so this is the sum of angles for our shapes up to 10. Okay, we may be asked to calculate for more. Okay, but and do we need to memorize all these angles? We don't. We just need to know how do we calculate them. Okay, but it will be good if it's in your fingertips. Okay, for some of it. Okay, so we have our interior and exterior angles. So the interior angles are the angles inside the shape. The exterior angles are the angles outside the shape. And the sum of these two angles are 180 degrees because of adjacent angles along a straight line. For the sum of interior angles, alright, we get the relationship where you take 180 times n minus 360, or you can you have n minus 2 times 180 based on what we explored earlier, right? For example, because we have two less triangles to make times 180. Okay, now then the last property that we'll go through today is the sum of exterior angles. Okay, we are interested to find how much does all these angles add up to. Okay, so from a first glance, if you want to follow me, okay, let's say you start from here, okay, and then you rotate a certain amount and you will move towards this direction. Okay, and then you rotate again, you move towards this direction, right? Let's rotate again and move to this direction. You rotate again, you move towards this direction, and you rotate again and you move towards back to the original position. So how much rotation that you get in total? You actually get a full circle, correct? A full circle's worth of rotation. Okay, now so this is one way to think about the sides or the sum of angles, exterior angles. Okay, now the second way to think about it is just from this animation over here. Okay, so for a triangle, you can see that the exterior angles add up to a circle. Okay, let me move out a bit. So the triangle, right, and you have each of the exterior angles. Let's experiment a bit more. Okay, let's go with a pentagon. Okay, you can see that all the exterior angles add up to a circle. Let's open it up, and then you can see that it's actually a pentagon. Okay, now let's move on to something a bit more bizarre, maybe like things with 11 shapes. Okay, and let's see whether let's see how much does all the exterior angles combine to. So they are combined to one circle, as you can see. Okay, so the sum of all your exterior angles is actually equals to 360 degrees. It's a fixed value regardless of the shape. Okay, so this is one of the properties that does not change regardless to shape. So for every shape, every polygon, the exterior angle set up to 360 degrees. Okay, so you have your interior sum of interior angles and you have your sum of exterior angles. Okay, and last but not least, I want to add one more point over here, and it's actually to talk about the symmetry, okay, or more like the symmetric properties of regular polygons. Okay, so what are actually regular polygons? Regular polygons have all same sides. Okay, so we have all the equal sides. Okay, maybe all sides equal. Okay, then we have all the interior and exterior angles equal. Angles are plural, equal. Okay, and last but not least, if you can find the center, okay, you can be chopped up to identical triangles. Okay, now one example would be something like this. Okay, 1 2 3 4 5 6. Okay, let's just assume that this is a symmetric hexagon. Okay, a regular hexagon. Okay, so let's say if you start from the center, okay, and if you draw lines like this, okay, okay, you can actually treat it as, you can divide it, you can chop up to 6 identical triangles, and the 6 triangles, right, the lengths inside are the same. Okay, and this 360 in the middle, the full circle in the middle, can be divided to 6 equally as well. Okay, so this is what we call the symmetric property of regular polygon, meaning like you can chop it up to symmetrical numbers. Okay, alright, so for a regular polygon, okay, it's very special, okay, because all the sides are equal and all the interior angles are equal. Okay, so that's why you can also chop it up like this. Okay, alright, so without further ado, with all this information, let's start to tackle some of the problems that we have. Okay, so practice now 12. Find the value of the unknown for each of the following figures. So this, what shape is this? This is a pentagon, 5 sides. So the thing to solving a polygon question is you have to know how many sides are there. Okay, so you have your pentagon. Okay, you have your 5 sides, so actually your n is equals to 5. Okay, so how do you find A? It is actually the sum of your interior angles. Okay, so you have to make use of your sum of your interior angles. So whichever formula up to you. You can use the 180 n minus 360, or you can use n minus 2 times 180. For me personally, I like n minus 2. Okay, so I'm just going to go with n minus 2 times 180 degrees. Okay, so the sum of interior angles, which is actually the sum of all these angles, okay, we have 107 plus 121, and how many a's do we have? We have 3 a's. Okay, and this is equals to n 5 minus 2 times 180. Okay, alright, so let's simplify. So actually what we're doing is actually we're forming an equation. Okay, so for polygon questions, usually we will be forming an equation. Okay, so and much clearer to form an equation as compared to solve it individually and you do the divide by 3 manually. Okay, so make it a habit. Try to see the equation, try to write the mathematical sentence. Okay, so we got one. Let's simplify this. We have 228. We have 3a. And then on the right we have 540. So actually if you know the 540, you don't even need this. Okay, you can just put 540. Okay, then we try to solve. We will minus 228 on both sides. Okay, so our 3a will be equals to 540 minus 228. So we have 312. Okay, and the next step is to divide the whole thing by 3. So our a will be equals to 104. Okay, 104. Okay, alright, so hope this is clear. Alright, so it is to use the sum of interior angles and form an equation and solve. Okay, now similarly for the next one, okay, for our hexagon. Okay, hexagon, this is a object with 6 sides, so n is equals to 6. Okay, so let us make use of our sum of interior angle formula again. Okay, we have sum of interior angles, so this would be n minus 2 times 180. Now, if you want 180 times n minus 360 also can, no problem, just go ahead with it. Okay, okay, so now sum of interior angles, so let's add up everything. Okay, add everything plus 122 plus we have a total of 7b. Okay, 4b and 3b add up to 7b. Okay, and this is actually equals to 6 minus 2 times 180. So the n over here is 6. Okay, let me use another color. Okay, n here will be 6. Okay, so let's add up everything, simplify. We have 468 and 7b. Okay, then we have 6 minus 4 times 180, so this is 720 degrees. And once again, if you know the 720, you don't need this formula. Okay, you can just put 720, but the formula is there just to guide you to sub in. Okay, alright, so same thing, make a habit to form an equation based on this sentence. Let's solve. So we take away 468 on both sides to cancel out the 468. Okay, we have our 7b is going to be equals to 252. Okay, and then we can divide by 7 on both sides. So we have b equals to 36. Okay, alright, so this is the very basic idea that you need to know. So given any polygon, okay, you will need the skill of finding the sum of interior angles, and you will need the skill to solve for each angle. Okay, sometimes they will ask you to find the angle for each of the regular polygon. Okay, alright, so we move on to solve more problems. Alright, so we have 2 of the interior angles of an n-sided polygon, 74 and 136. The remaining angles are 110 each. Find the value of n. Okay, so for a polygon, usually we have an n-sided polygon. So now we have an unknown. Okay, n-sided polygon, which means that they have n sides. And how many interior angles do we have? We have n amount of interior angles. Okay, so we need, and then the interior angles, right? One of it is 74, another one is 136. Okay, and we have 110, right? But how many of these actually? So if we have n of the interior angles and we know 2 of them, so the remaining unknown one are 110. So we have for this one we have n minus 2 of them. Okay, so let's try to form an equation over here. So making use of the formula, sum of interior angles is equals to n minus 2 times 180 degrees. Okay, so sum of the interior angles, we have our 74, we have 136, and we have n minus 2 of 110. Okay, we have n minus 2 of 110. Okay, all this is going to be equals to n minus 2 times 180 degrees. Okay, because we don't know the value of n, so now forming this equation, we can find the value of n. Okay, so before we begin with anything, we simplify the first two. Okay, so 74 plus 136, 210. So we have 210 on the left. Okay, on the right, we will need to expand. So when we expand, remember to expand carefully. Okay, when we expand, we need to remember to expand carefully. So we got 210 on the left, we have 110n minus 220. Okay, and we have 180n, don't forget the n, and we have 360 over there. Okay, so how do you want to simplify? Up to you. So for me is to bring the 110 to the right hand side. Okay, so on the left I will have negative, okay, let me just minus 110n minus 110n. So to bring the n to the right hand side, on the left hand side, 210 minus 220, so this one is negative 10. So we have 70n minus 360. Okay, so let's move the 360 now, okay, to plus on both sides. I need to balance plus on both sides. So we have 350 is equals to 70n, then we divide by 70, so 5 equals to n, or n is equals to 5. So this is actually a pentagon. So let's say if they ask for the name, you need to say that this is a pentagon. Okay, so for this we don't guess and check. Okay, so for this kind of question now, we don't guess and check, we make use of the formula and form the equation. So the formula is very, very important. Okay, alright, so that's for 1, that's for 2. Let's move to, okay, more questions. Okay, so we have now we are looking at interior angles, right? And we are looking for a regular polygon with 24 sides. So the key thing now is, instead of a general polygon, now we're looking for regular polygons. Okay, polygons with the same sides. Okay, same sides, same interior angles. Okay, the symmetrical polygon. Okay, so what is a regular trigon? Okay, regular trigon is a equilateral triangle. Okay, and a regular quadrilateral is a square. Okay, alright, so oh yeah, and by the way, the naming for the shapes with more than 10 gons, for simplicity purposes, we can call it a 24 gon. Okay, so for this shape is a 24 gon. Okay, let's say we have object with 53 sides, we call it a 53 gon, and so on. Okay, so yeah, just for your general knowledge. Okay, now for the sum of interior angles for a regular polygon with 24 sides, so sum of interior angles, so same thing, make use of the formula, n minus 2 times 180 degrees. So here the n is going to be equals to 24. Okay, times 180. So 24 minus 2 times 180. Okay, so this one is actually 3960. Okay, 3960. Okay, then for part 2, calculate the size of each interior angle. So each interior angle will be equals to 3960 divided by 24 sides. So this would be 165 degrees. Okay, 165 degrees. Right? We clear? Now, there's an alternative way if they ask us to find, there's an alternative way to do this. Okay, if they ask us to find the interior angle directly. Okay, let's see whether do we have such questions below. Okay. Now, let's say if they don't have part 1 and part 2 and we are supposed to find the interior angle directly. Okay. Either you can just do step by step. Okay, you can do step by step to find the sum of interior angle and to find each interior angle. Or you can just go directly with this. So we have n minus 2. We have this formula, right? Times 180 degrees. Okay, and we can just divide by n sides. So we get another formula over here. But the thing is, my advice is don't rush. You just remember the formula for the sum of interior angles. Okay, so you can have this actually. So this is the faster way to do this, but it's also riskier and it's not general, it's very specific. Okay, so which is actually not as nice. Okay, hold on, yeah. Okay, 165 degrees. Okay, now an alternative way, this is method 2. Okay, another alternative way is this. Okay, you can look for your exterior angles first. Okay, so because you know that the sum of your exterior angles is going to be 360, and each exterior angle is going to be 360 divided by 24 sides. We have 15. Okay, so the interior angle, so each interior angle is just simply 180 degrees minus 15, so which is also 165. Okay, so you can also see that sometimes your sum of exterior angles, okay, may be a more convenient way of finding your interior angles, especially for regular polygons. Okay, so there's 3 methods over here. Okay, my advice is you focus on this main method over here, because this formula is important, more so than this. Okay, this one is the important one to remember. And another important one to take note is this, looking at the sum of exterior angles, and you just divide. Okay, make sure you label as you go so that your presentation is clear. Okay, so here I present to you 3 methods on finding interior angles of a regular polygon. Okay, 2 of which that I feel that are more important and more useful. Okay, now let's go on. Now practice now 14. Okay, now so find the number of the sides of a regular polygon. So we have a regular polygon over here. Okay, so if each of the exterior angle of a polygon is 40, we need to find the number of sides. So we need to find n. Okay, alright, so if each exterior angle, okay, so each exterior angle, so for the exterior angle, right, since we are looking for a regular polygon, it's just 360 degrees, right, divided by n, correct? So if each exterior angle is 40, 360 divided by n, so 360 divided by what is 40, or you can just think of it as solving a fractional equation. So we cross multiply the n to get 40n equals to 360, and then we divide by the 40. Okay, divide by 40, so n over here will be equals to 9. Okay, or you can just think of it as 360 divided by what is 40, 360 divided by 9 is 40, also can. Okay, so think of it in these terms. Don't be lazy, do the algebra. Okay, don't take shortcuts. Okay, once you master the foundation, only then you take shortcuts. Okay, now for B. Now if each interior angle is 178, okay, find the number of sides. Okay, so we will need to make use of this one. Okay, so for the sum of interior, so from the sum of interior angles, okay, we have n minus 2 times 180 degrees. Okay, then for each interior angle would be this formula, n minus 2 times 180 degrees, correct? We will multiply by 180, but we need to divide by n. So that's the thing, we need to divide by n. Okay, so for each interior angle will be 178. Okay, then we have n minus 2, right? Think of it as n minus 2 times 180 degrees, and we divide this by n. Okay, so what we can do is we can do our usual cross multiply. So we get our 178n. Okay, sorry, pardon me and my pen. Okay, 178n is equals to n minus 2 times 180 degrees. Okay, let's expand a bit more. 178n is equals to 180n minus 360. Okay, then okay, we'll just pull the 180 to the left. Okay, so we have our negative 2n equals to negative 360. So what we need to do is just divide by negative 2 on both sides. Okay, divide by negative on both sides. So I'll follow up here. So n will be equals to 180. So this weird shape has 180 sides. Okay, so this weird shape has 180 sides. Okay, weirdly. Okay, now an alternative way to go about this, if you're given the interior angle, is you fall on the exterior angle, which is the much easier way actually. Okay, so let me put here alternative. Alternative. Okay, alternative is to use your exterior angle. So each exterior angle would be, the sum is 360. You divide by n of them. Okay, because the sum of exterior angle is 360. Okay, so you can do your sum of exterior angle, which is the one that you should memorize. Okay, then each exterior angle will be 360 divided by n. Okay, and now the exterior angle is actually not 178. The exterior angle is 180 minus 78 is 2 degrees. Okay, so 2 is equals to 360 over n. So 360 divided by what is 2? So n will be equals to 180 degrees. Okay, alright, so the exterior angle is actually a much shorter way to solve these kind of questions. Okay, especially when it comes to regular polygons or when you're looking for each interior angle. Okay, however, the more important formula to take note is this, right? Because as you can see from the earlier examples, you will need to use this one, okay, to solve the other problems. Okay, alright, let's move on. Okay, two of the exterior angles of an n-sided polygons are 25 and 26. Three of the interior angles are 161. The remaining angles are 159 each. So calculate the value of n. Okay, so now, so here we cannot be using the exterior angles, okay, because here the interior angles are different. So the exterior angles must also be different. Oh wait. Oh, actually we can use, okay, because okay, we have two exterior angles. So they give us two exterior angles. So we have exterior angles. We have 25 degrees and we have 26 degrees. Okay. We have n-sided polygon over here. So this one is something for you to take note. We have three interior angles of 161. So we have three sets of 180 minus 161. So we have three sets of 19 degrees. Okay. And we have a remaining of 180 minus 159. So we have a remaining of 21 degrees. Okay, but how many sets are there? We have n-sideds, we know 1, 2, 3, 4, 5. So the remaining is actually n minus 5 sets. Okay, alright, so we, instead of using the interior, you can use your interior angle. Okay, and also you can use your exterior angle, up to you in this one. Okay, so for this one, okay, if you were to use your interior angle, it will look something like this. Okay, question 2 in the previous page. So here we are just going to focus on exterior angle so that I can show you like different ways of doing it. Okay, so the key thing is you have to be flexible. Okay, alright, so your sum of exterior angles would be 360 degrees. Okay, so we have your 25, we have your 26, we have your 3 times 19, and we have your n minus 5 times of 21. Okay, so this is equals to 360. Okay, let us open up, simplify. We got 25, 26 plus 3 times 19. So we got 108 plus 21n minus 105 equals to 360. Okay, so we have 221n minus 3, weirdly, equals to 360. Okay, let me bring the 3 there. So your 21n is going to be equals to 363, and then I divide by 21, so n will be equals to 363 divided by 21. Not a nice number, so I'm just going to put as fraction. So 17 2 over 7. I think something must be wrong somewhere. Okay, sorry, I've made a mistake somewhere here. This should be a plus 3. Okay, this would be a plus 3. Okay, plus 3. So what I have would be a minus 3 on both sides. So this would be 357, also divided by 21. So 357 divided by 21, I get 17. So 17 sides. Okay, the value of n. So n has 17 sides. Okay. Alright, that's good to go. Okay, so we can use our sum of exterior angles to make it easier to find some questions instead of always relying on interior angles. So the general advice is be flexible. Okay, be flexible to use between interior angles and exterior angles. And the key thing is you have to remember the two formula, one for interior angle, one for exterior angle. Okay, now the last example that we have is actually a combination of more polygons. Okay, so in the figure over here, ABCD is a part of an n-sided regular polygon. So this part, okay, if you're not too sure, okay, they say that ABCDE, so ABCDE is side of an n-sided regular polygon. So this whole thing is your regular polygon. Okay, BPQRC, so this one BPQRC, this thing, okay, is a regular pentagon. This thing is a square, a regular quadrilateral. Okay, a square. So regular, regular, regular. Okay, so take note. Okay, so first we need to calculate PBC, so meaning this angle over here. Okay, so we are talking about a pentagon. Okay, so up to you. Okay, up to you. If you want to use your interior angle, exterior angle, be up to you. Okay, so you can say that sum of exterior angle of pentagon. So you must label because we have more shapes now. Okay, 360. So each interior, so you can say that the PBC, angle PBC, is just 360 divided by 5. So this would be, no, exterior angle. Sorry, too fast. Okay, each exterior angle of pentagon, 360 divided by 5 is equals to 72. So angle PBC will be equals to 180 minus 72. So 180 minus 72, we got 108 degrees over here. Okay, alternatively, okay, you can use your sum of interior angles, n minus 2 times 180. Okay, another alternative one. Okay, you can, because we are looking for 5 sides, so this is 540. So angle PBC can be 540 divided by 5. Okay, so this is 108. Also can. Okay, see which one you prefer. Okay, and make sure you label that the pentagon or which pentagon and so on. Okay, which polygon. Now QCR. So we are looking for QCR, this one over here. Okay, so now is to form a triangle, and we need to look at this angle there. Okay, however, since this is a regular polygon, if this is 108, this angle here is also 108. Okay, and this is a regular polygon, so QR and RC are actually equal. So we actually have a isosceles triangle. Okay, so for number 2, okay, I'm just going to say that QRC first is equals to 108 also. Okay, so your angle QCR will be equals to 180 minus 2 times 108. Okay, so 180 minus 2 times 108. So I'm gonna have, what am I doing? 180 minus 108. Okay, and then this one divide by 2. Okay, so 180 minus 108 divided by 2, I'm going to get 36 degrees. Okay, reason, because this is a angle sum in an isosceles triangle. Okay, angle sum in triangle, yes, but for this case is special. It is an isosceles triangle, so I'm just writing it together over here. Okay, now next one, we look for BCD. If they never say anything, right, we will assume that it is the smaller angle BCD. Okay, we normally don't assume a reflex angle, we'll assume a normal usual angle. Okay, so for angle BCD, right, how do we get this? Is we need the angle at one point minus of this interior angle minus of that interior angle. Okay, so before we go on, let's set up a bit. Okay, so each interior angle of a regular pentagon, or you can just put there BCR also can. I just put that BCR then. Okay, so my angle BCR is 108 degrees because of the pentagon. Okay, my angle RCD. Okay, RCD being this one over here. This is 90 degrees because it's a square. Okay, because it's a square. Okay. Okay, we actually don't need to write this. Okay, we can just state it down here. At least state it somewhere. Okay, so your angle BCD. Okay, your angle BCD will be equals to 360 degrees minus of your 108 minus of 90 degrees. Okay. We have a 162 over here. Now, this one, the reason over here would be angles at a point. Okay, this reason here. Okay, all right. So now with this one, let us look at triangle BCD. Oh dear. Okay. Let me remove this. Okay, let me draw this nicely. BCD. Okay, now we know that we already know this angle over here. Okay, this angle here is 162. Okay, now BDC, so we need to look for this angle then. Okay, so same thing, we are going to have, since this is a regular polygon, so the two sides are the same, so you get an isosceles triangle there. Okay, so I'm just trying to squeeze, or let me just squeeze up here, then I'll move it down. Okay, so our angle BDC, okay, will be equals to 180 minus 162, and this amount I divide by 2 because this is a angle sum in isosceles triangle, so this one must write. Okay, so 180 minus 162 divided by 2, we're gonna get 9. Okay, 9 degrees, a very miserable 9 degrees. Okay, so and then let me put it down here. Okay, part 4. Okay, then last but not least, for part 5, find the value of n. So they are asking for this particular thing, how many sides? Okay, so how many sides does this have? So here, for the, I'm going to use the shorter working of exterior angle. Okay, so I'm just going to look for exterior angle of n-sided polygon, or I just call it an n-gon. Okay, it's going to be 180 minus of the interior angle 162. So this is going to be 18 degrees. Okay, then I'm going to make use of sum of exterior angle, or more like the exterior angle itself. We don't need the sum. Okay, so each exterior angle is going to be 360 divided by n. Because of the symmetric property, we can divide by n nicely. Okay, so exterior angle is 18 degrees. 360 divided by n. So 360 divided by what is 180? We don't know yet. We can or you can just think of, you can just see that it's 20 if you can see it. If you can't, then you just algebra this thing. So 18n equals to 360, and we're going to divide by 18 on both sides. So your n is going to be equals to 20 over here. Okay, so a shorter method to use the exterior angle. Okay, if you were to use the interior angle, then let me just show you. Okay, so interior angle of an n-gon, n minus 2 over n times 180 degrees. It's just the same formula, divide by n, that's all. Okay, so I have 162 is equals to this ungodly thing, and then I will need to, put it over this side. So I have 162n, n minus 2 times 180 degrees. So 162n expand. Okay, and I will move the 180 to the other side. So I will have negative 18n is equals to negative 360. Then I divide both sides by negative 18 to get my 20. Also can. Okay, but obviously the exterior angle one is going to be simpler. Okay, so up to you, up to your flexibility. Okay, alright, so there we are. Alright, so this is like the, like the god tier, or like the what they can possibly do with our properties with polygons. Okay, so so the homework for this holiday is to attempt the questions behind. Okay, just try your best. You can explore ways to make your working as simple as possible, but you need to write down reasons for some parts. And last but not least, the summary is all the way at the front page for you to see. Okay, this summary over here. Okay, so one more time, the important points to take notes are the relationship between interior exterior angles. Okay, your sum of interior angle, choose one formula to use. Okay, for me I prefer formula number 2, but if you like formula number 1, just use it. Then you have your sum of exterior angles, which is equals to 360. They will form a circle. Okay, and your symmetric properties of regular polygons. So these few points regarding polygons that you need to know. Okay, and that's it for polygons. It's a lengthy portion. Okay, but it's very interesting. I find it very, very interesting. And I hope you do. You find it so. Pardon the algebra, but that's the best. That's why I think the best way to solve these kind of problems. Okay. Alright, so have a good day ahead and hope you learn well. At any point, if you're stuck, feel free to pause, rewind, and go back. Okay, that's all. Bye bye.